Those are online. Am I audible?
Sir.
Okay.
Yes,
Take out
sir.
the study material which we gave. Okay, we'll do some problems from that. One minute. Which topic is more tricky for you? From the second chapter, which topic is more tricky? So just check your notes and tell me, we'll solve problems from that topic. Or you want me to do it randomly? Randomly. Okay, see, most first topic. See, potential difference we did enough, Noda. Like I did the problem, no? There is only one kind of a problem they're asked. Like on the line joining the charges, where is the potential zero? I think I've taught that clearly, right? Another problem also you guys do good. See, one of the topics which I see most of them struggling is the series and the parallel combination, like how to redraw the circuits and everything. So I'll do the problems based on it. Okay. So there is a question like this. So this is 10 microfarad. This is also 10 microfarad. This is point A. This is point B. And here the capacitance is given as C. Okay. So the question is, the equivalent capacitance of this network is 15. So C equivalent is 15 microfarad. If that is the case, then what is the value of this C? Are you able to understand? So what is the value of this C? See, if you just observe, right, you will get the answer. So what are how are they actually? This 10 microfarad and this 10 microfarad, how are they connected? They are in parallel. In parallel, what happens? You add them, right? So when you add them, how will the new circuit look like? This will be 20 microfarad, which is connected across the capacitor C between the points A and B. So this circuit has got converted to this. Am I right? Now, what are the equivalent capacitance of this network? So it is 15. So whenever you have two capacitors in series, right, you need not apply that 1 by C is equal to 1 by C1 plus 1 by C2. What you can do is, you can write C equivalent is equal to product of two, that is 20 into C divided by the sum of two. So basically what I'm trying to tell you here is, you will get 1 by C equivalent is equal to 1 by C1 plus 1 by C2. Am I right? So when you take LCM and then solve it, what will you get? You will get C1 plus C2 divided by C1, C2, this is 1 by C equivalent. Then what is C equivalent be? C1, C2 by C1 plus C2. So whenever you have two capacitors connected in series, right, just multiply the capacitances divided with the sum of the capacitances. So 20C divided by 20 plus C. What should this value be equal to? This should be equal to 15 according to the question. So 20C divided by 20 plus C is equal to 15. So this 4 times, this 3 times cross multiply. So 4C is equal to 60 plus 3C. Bring this C. So C will be 60 microfarad. So this will be 60 microfarad. Am I clear with this? Clear? So make a note of this. Shall I proceed? Okay. So the next question is, shall I proceed? You're copying? Okay. So listen. So next one is, you have a 20 microfarad and a capacitor C, which are connected in series like this. The equivalent capacitance given here is 15. Find the value of C. Just now I told you. 20 into C divided by 20 plus C. So what will the answer be? So this is the next question actually. So C will be 60 microfarad. Just now we solved, no, 20C by 20 plus C is equal to 15. Am I clear? Next. There is a capacitor like this. Sorry, there is a network like this, which is 5. Everything is a microfarad. 10, 15, and 30, which are connected between the points A and B. So you need to find the equivalent capacitance between the points A and B. Okay, you will see these kind of questions also. I'll tell you how to solve this. Okay, listen to this carefully. Did you all draw this? Listen. So here, take the endpoints. Whenever they ask you, listen to this question carefully. Whenever they say find the equivalent capacitance, they need to mention the points across which you are expected to calculate. So here the question is very clear. You need to find the equivalent capacitance between the points A, B. Okay. Now, if I take this to be C, D, E, and F. Okay. Yesterday I told you one point. Whenever there are 2 points which are connected with the help of a wire, they both are at the same potential. Meaning A and C are at the same potential. Similarly, C and E are at the same potential. So how I will take is, I will take this as A, C, E in a bracket. Similarly, B, okay. If I look at the points, D and F, they both are at same potential. Am I clear with that? So that's how the diagram is. 1 minute. Yeah, that is how the diagram is. So I'll take D and F to be at the same potential. What I can do is I can actually take it as a middle point itself, like midpoint itself. So D comma F is going to be here. From A or C, how many capacitors are going to D? From C, observe, from C, there is one capacitor going to D. So I'll draw that capacitor. How much is that value? 5. Once you're done, put a tick with a pencil. From D to E, there is one capacitor that is going, which is like this, which is 10. You're done with this. From E to F, between E to F, there is one capacitor, which is of value 15. And from F to B, there is one capacitor, which is 30. Did you understand how I redrew? Now you will get clarity of which are in parallel and which is in series. Now it's easy to solve. 10, 5, 15 are in parallel. So how much will you get? Cancel everything, you will get 30. 30 and 30 are in series. You will get the answer as 15. When two capacitors of equal value are in series, or for that matter, if n capacitors of equal value are in series, then the equivalent capacitance will be C divided by n. Here it is 2, so that is why C by 2, 30 by 2. All right, so answer will be 15 microfarad. See, but in exam, don't do it like this. Don't write 15 and ask them to, don't expect marks. You need to show the steps. Okay. Yeah. I didn't understand. Reference, sir. Formula. You have to redraw this circuit. If they add it, you have to redraw the circuit. So the only concept that you're supposed to know is if 2 points are connected without any device between them, they both are at same potential. That is why I took it like this. You will see similar kind of problems in resistors also. Is there a question? Is the parallel? You have to see, maybe you can shift this connection, that's it. Up a short circuit. If you are not ready to take such problems, resistors there is a concept called as Wheatstone bridge. And explain there is actually a simpler version of redrawing the circuits. So இப்போதைக்கு இது ஞாபகம் வச்சுக்கோ. When a concept comes, I'll teach. Okay. So the next set of problems that you will have is something like this. So if you go to page 79. So there is a question like this in page 79. No. Figure shows two identical capacitors C1 and C2, each of 2 microfarad capacitance connected to a battery of 5 volt. So they are connected like this. See, there are two capacitors C1 and C2. Which are connected to a battery of 5 volt. Right. See, listen to this question. This is very important. Everybody listen. Those who don't have textbook, listen. Initially, the switch S is closed. Initially, the switch S is closed. After some time, S is left open and dielectric slabs of dielectric constant K is equal to 5 are inserted to fill completely the space between the plates of the two capacitors. First question is, how will the charge? The second question is, the potential difference between the plates of the capacitors be affected after the slabs are inserted. So what is happening initially? The switch S was closed. After some time, they are opening it. So when they closed it, what would have happened? First, understand the science behind it. Let's first try to dissect that part and see. When it was closed and the battery was connected, what would have happened? You need not see, just tell me what is the science behind it. This battery is there. What would it do to the two capacitors? It'll just charge it, no? It is going to charge both the capacitors. There will be some charge stored in this. There will be some charge stored in this. And there will be a potential difference of 5 volt here and 5 volt here. What are they doing after the? I don't know till, see, they didn't mention anything. It is connected to a 5 volt battery. Initially, switch S is closed. After some time, I don't know how much time it is. I don't know whether the capacitors are fully charged also. Okay. After some time, switch S is left open and they started inserting the dielectric slabs into both the capacitors. When they do that, how are the charges and the potential differences getting affected is what the question is. So to solve this problem, we need the knowledge of the table that I gave you yesterday. So I gave you a table, right? Just check your notes. So there, I gave you a concept of dielectric inserted with the battery connected and the battery disconnected. Am I right? So tell me, what would be the charge here? This is 2 microfarad. This is also 2 microfarad. So when the switch was closed, when the switch is closed, I am assuming enough time is given to materials to get charged. When switch is closed, what is the charge on the first capacitor? Sorry? When the switch was closed, the dielectric was not inserted. It is C0, so C1 into V1. So it is going to be 10 microcoulomb. What about Q2? That is also 10 microcoulomb. Now switch is open. Right. So that is one part. What is the potential difference across 1? It is 5 volt. Potential difference across 2 is also 5 volt. Now dielectric is inserted after the switch is open. Listen to this carefully. This capacitor, even though the switch is open, is still getting charged. Because the switch is on the other side of C or C1. Right. Means here what will happen to the charge? So when the switch is open, when you take for the capacitor 1, what is going to be the charge? Q dash or Q1 dash is equal to K times initial charge. Because it is still getting charged. So how much will the answer be? Dielectric slab is of dielectric constant 5. So it will be 50 microcoulomb. Am I clear with this? What about Q2 dash? Check. When the dielectric is inserted, it will hold charge. it will be exactly the same value which was present initially. It is 10. Are you able to understand what I'm saying? Similarly, what will be the value of V1 dash? This is still connected to the battery. It will still be 5 volt. What about V2 dash? It will decrease by a factor of 5. So answer will be 1 volt. V naught by K per right side. For potential, it become V naught by K. Initially, it was 5 volt. It will decrease by K. So it will become 5 by 5, which is 1. So this is a previous year question. Are you able to understand? Those who are online, are you able to understand?
Yes, sir.
Sure.
Yeah. Okay. So I'll give you a similar kind of a problem. So there are two identical parallel plate capacitors A and B connected to a battery of V volts with the switch S closed. The switch is now open and the free space between the plates of the capacitor is filled with the dielectric of dielectric constant K. So till here it is same. Only difference is, it's a similar question. Only difference is here the potential is V and both are identical capacitors of capacitance C. Every situation is same. Now they are asking the ratio of the total electrostatic potential energy stored in both the capacitors before and after the insertion of dielectrics. So before inserting dielectrics, how was the switch? It was closed. So when the switch was closed, you calculate what was the total energy stored in the system. When the switch is opened, the dielectrics are inserted. Now calculate what is the total energy of the system. Take the ratio of both. So you need to take the potential energy before and you need to take the potential energy after. $25 C and C, you'll have the answer in terms of C and B. Here the values are not given. The value is C and B. You will get a generic value. So how much will it be? Before is how much? Tell me. How much will be the energy in it? 25 varadra. Inga number illa, there is no number, try to understand. So it is only C. Forget the previous problem. If there is no number, the answer will be in terms of C and B only. Tell me in terms of these values that are given. How much is that? Half CV square plus half CV square. This is the energy before. So after, what will happen is the dielectrics are inserted. After the switches is open, the dielectrics are inserted. So what will be the energy here? Yes, correct. Half kCV square plus what will be the potential energy there? Half CV square by K. Because when the battery is disconnected, the potential energy will decrease by a factor of K. Am I right? So when you divide both, that is what they're asking. What is going to happen? I can take out half CV square outside. So I'll have 2 here divided by. If I take out half CV square, what will I have common here? K plus 1 by K. So half CV square and half CV square will get cancelled. 2 divided by, there's going to be K square plus 1 divided by K. This will go to the numerator. Answer will be 2K divided by K square plus 1. That is why if you see in this problem, they didn't give B or C also. They told identical capacitor. They didn't give the value also. Because final answer has only dielectric constant. So whenever you're solving a question, whatever is given in the question should be in the answer. If they have not given capacitance and your answer has capacitance in it, you're wrong. So whichever parameters are not given should not be in the answer. Clear with that? So you can expect these kind of questions also. Okay. Done with this? So write down this question. There is an electric dipole of length 4 centimeter. An electric dipole of length 4 centimeter. When placed with its axis making 60 degrees with uniform electric field. When placed with its axis making an angle of 60 degrees with uniform electric field. Experiences a torque of 4 root 3 Newton meter. Okay. Full stop. Calculate the potential energy of the dipole. If it has a charge of plus or minus 8 nanocoulomb. It has a charge of plus or minus 8 nanocoulomb. Did you understand the question? Yeah. Angle of 60 degree with a uniform electric field experiences a torque of 4 root 3 Newton meter. Experiences a torque of 4 root 3 Newton meter. Calculate the potential energy of dipole. If it has a charge of plus or minus 8 nanocoulomb. So what will the answer be? What is the formula for potential energy of a dipole? U is equal to PE cos theta. And what is the formula for torque? Where in both the cases theta is the angle made by the dipole moment with the electric field. Right. So if I do u divided by tau, what will I get? I'll get cot theta. So u is equal to, so what is the value of torque they gave? 4 root 3 into, what is the value of theta? Cot 60. What is cot 60? Cot 60 is 1 by root 3. So that's the answer. So in this question, the unwanted data is, see, cot 60 is tan 30 theta. So unwanted question is charge and the distance. So unwanted point. You don't need it at all. So there is another interesting question. Write it down. A capacitor of unknown capacitance. There was also a previous year question. A capacitor of unknown capacitance is connected across a battery of V volts. Is connected across a battery of V volts. No number here. It is only V. The charge stored in it is 300 microcoulomb. The charge stored in it is 300 microcoulomb. When the potential across the capacitor is reduced by 100 volt, when potential across the capacitor is reduced by 100 volt, not reduced to 2, it is reduced by 100 volt, the charge stored in it becomes, okay, I'm stopping here. You see the question and tell me, should the charge decrease or increase? Initially, what was the charge? 300. Now the potential is decreased by 100. So charge should also reduce, right? So what is the question is, when potential across the capacitor is reduced by 100 volt, the charge stored in it becomes 100 microcoulomb. Full stop. Calculate the potential V, the unknown capacitance. That is the first part of the question. So first part of the question is calculate the potential V and unknown capacitance. Second is, what will be the charge stored in the capacitor? What will be the charge stored in the capacitor if the voltage applied had been increased by 100 volt? What would be the charge stored in the capacitor had the potential been increased by 100 volt? Okay. So read the question, try to solve on your own. Just take the data and then solve it. Go step by step. Those who are online are able to understand?
Yes, sir.
See how many situations are given in this question. I'll tell you how to think, okay? You need not look at multiple formula or something. Basically, what you have, the question speaks about charge, capacitance, and potential difference. How many unknowns do we have? What are the three? Actually, you have only two. What are the two unknowns? Potential and unknown capacitance. Two unknowns. So whenever mathematically you need to find two unknowns, how many equations do you need? Number of unknowns is equal to number of equations. That's the logic. Okay. So for that, with the first condition that is given, frame one equation. With the second condition that is given, frame one equation, solve, you'll get the answer. Did you understand what I'm trying to say? Did you understand the logic? So, thing is, what did they say initially? So always break it into two parts. What is happening initially? Initially, there is a charge of 300 microcoulomb when you connected a battery of potential V across an unknown capacitance of capacitor of capacitance C. So finally, what happened? You did some changes. You reduced this by 100. So you made this V minus 100. By doing this, did you affect the capacitance? Nothing, because it is independent of all these things. But what happened to the charge stored in it? Reduced by 100 or reduced to 100? Reduced? Read the question. No, it becomes 100. Potential is reduced by 100. Charge becomes 100. So you should not write 300 minus 100. Don't write 200. Becomes 100 means here it is 100. So what is the equation that relates all these three? That's it. That's all you need to do. So Q is equal to CV. This, if I use it, initial condition, I'll use Q1 is equal to, or I'll use QI is equal to CI into VI. Right? What is QI? 300. I'm not writing that micro and all. So 300 is equal to C into V. I have two unknowns. I can't solve. Next case. Q final is equal to C final into V final. What is Q final? 100 is equal to, what is the value of C final? C only. What is the value of V final? V minus 100. So I want to eliminate C. I'll divide both. 300 by 100 is 3 is equal to V divided by V minus 100. Did you understand what I did? 300 by 100 is equal to right hand side I divided. So when I solve this, I'll get 3V minus 300 is equal to V. 2V will be equal to 300, which implies V will be. So this is the initial capacitance, initial potential difference that you applied. Take this, put it here, you will get the value of C as 2. That's it. Did you understand how to approach? Right, next time will you be able to do it on your own? So C will be equal to 300 divided by 150, that is going to be 2 microfarad. So this is also a previous year question. But there is another part of the question that you solve it. Minus 150. Yeah. What is minus 150? Second part of the question. When potential is increased, how will charge decrease? Adu negative. See, what is the value of V? 150. It is increased by 100 means it will become 150 volt is 150 is the initial potential. They are asking what will be the charge when the potential is increased by 100. Now what is the new potential? That's new potential. 150 initial, na, 100 add panna 250. So 250 multiplied with 2. That's the answer. It will be 500 microcoulomb. What is the answer? About 500? 500? Okay. So I'll read another question. I don't want you to write. Listen and tell me the answer. So there is a slab of material of dielectric constant K, which has the same area of cross section as that of the capacitor. So I repeated, there is a dielectric slab of how much dielectric constant? K, and what is the area of cross section? It's the same as that of the capacitor. It has a thickness of 2d by 3. It has a thickness of 2d by 3. It is inserted between the plates of the capacitor. So what will be the new capacitance? That part alone you can solve and tell me. Don't look at the formula. You don't remember. Yes. So, yes. 2d by 3 is the thickness. Solve it. Yesterday I told you a method to remember also. Yeah. 2d by 3 and the dielectric constant is K. So what will be the new capacitance? 1 minute, wait. Find the expression. Area of cross section is nothing is given. They have given only K and 2d by 3. But you will not be able to solve it like that. You can take the area of cross section to be A and the distance of separation between the plates to be D. So your answer should be in terms of K, A, epsilon naught, and D. No need to substitute. Whenever it is a generic value, don't substitute. D of K plus 2 by 3. I have to check that. So is that the answer others also got? So basically you will have C dash is equal to epsilon naught A divided by D minus T. D minus T is how much? 2D by 3. So D minus 2D by 3 is how much? D by 3 plus D by 3K. So 2D by 3K, sorry, yeah. This is what you did. So 3K into epsilon naught A divided by D into K plus 6. Not 6, K plus 2. Is that the answer? The 3 I took it up. So 3 times K into epsilon naught A divided by D into K plus 2. See, sometimes what they do is this epsilon naught A divided by D is taken as C naught. So you will have it as 3K times C naught divided by K plus 2. Clear with this? You can expect these kind of problems. Okay. Especially in MCQs. Now there is another question. See, this also I want you to listen and then do it. Listen, a parallel plate capacitor of capacitance C. So there is a parallel plate capacitor of capacitance C is charged to a potential V. So it's charged to a potential V. Full stop. It is then connected to an other uncharged capacitor of capacitance C. So are you able to recollect some problem that we did yesterday? That 900 picofarad, 600 picofarad problems are there. No? They replace those values with C and V. That's it. So there is a capacitor of capacitance C connected across a potential difference V. It is initially charged. It is then removed from the battery. It is connected to another uncharged capacitor of same capacitance C. Now what you need to do is find the ratio of energy stored in the combined system. Combined system is charged plus uncharged capacitor. So you need to find the ratio of the energy stored in the combined system to the initial energy. So initially, what was the situation? There was only a capacitor and a. See, guys, I want you to concentrate. That is the reason I'm saying don't write it. So reciprocate. So initially, what was there? You had a capacitor and battery. So you charged it. So what will be the energy stored in it? Write down that one. So U initial is half CV square. So if you take that capacitor and connect it to another uncharged capacitor of capacitance C, now what will be the total charge, total energy of the system? So basically, if I have to show you diagrammatically, it is like this. So here this is C, this is V. The next situation is this is C, this is C. So you need to calculate the energy of the system. You need to calculate the energy of the system and find the ratio of U final by U. This how much? That's what you need to do. Will you be able to do? Yes. So U initially you already know. How much is it? Half CV square. Now here, initially this is charged to a potential of V. So what will happen to the potentials here? It will be half because they both are identical. So here how much will be the potential? Half of how much? Potential, you are talking about half of V. So here it will be V by 2, here it will be V by 2. That is a common potential. Yesterday I gave you a formula, no? C1 V1 plus C2 V2 by C1 plus C2. If you do that, you will get V by 2 here, V by 2 here. So what will be the energy in this? So what will be the energy here? Half C V square by 4. What will be the energy here? Half C V square by 4. So it is CV square by 8 plus CV square by 8. The answer is CV square by 4. This is final energy. So final energy of the system is CV square by 4. Initial energy of the system is half CV square. So what will be the ratio? This and this will get cancelled. This will go 2. Answer is 1:2. That's what we saw yesterday, no? You would have got the answer for first case as 4.5 in that example. Then the second case you got it as 2.25. What was the answer in that 600 picofarad capacitor problem? I think you would have got it as 6 and 3. Check. That was the last problem we did in yesterday's class. The 600 picofarad one. You got the answer as 6 and 3. So every time it becomes half. So the final energy of the system will always decrease by 50%. Why I'm telling this is if you find similar kind of a problem in MCQ, if they ask you how much, what is the ratio, you can just go with it. So U final by U initial is half. U initial by U final will be 2. So be careful with what they're asking the option. Okay. So is that point clear? So one last question. It's very simple again. An electric dipole. So again, don't write it. Listen to this. An electric dipole consisting of charges plus q and minus q is separated by distance capital L. Capital L. Okay. And it is in stable equilibrium in an electric field. How is it? It is in a stable equilibrium in a uniform electric field. Now the question is, what is the electrostatic potential energy of the system? So what are the parameters given? They have given you the charges present. So charges are, now you can write it. So charges are plus and minus q. The charges are plus and minus q. What is the distance of separation? Capital L. And what kind of an orientation is it taking? Stable equilibrium means what should be the angle between both? A 0 degree between whom? Electric field and the dipole doesn't have an angle. Dipole moment has an angle. So angle between dipole moment. So what is the direction of dipole moment? Is it from positive to negative charge or negative to positive charge? So for stable equilibrium, theta should be 0. So they're asking what is the potential energy of this system? It's very simple. You can solve it in one step. Minus PE. So U is equal to minus PE minus of what is the value of P? Q into the distance of separation is L. So you should write 2A. No, you should write it as 2L. Correct? Concentrate. You will write 2L. What is dipole moment? It is a product of magnitude of either of the charges and distance of separation between them. In this problem, what is the distance of separation? It is L. Why I told this is in options you have 2L also. You will make that mistake. Okay, it is Q into the distance of separation. So Q into L is going to give you dipole moment. And what is the value of electric field? It is E, and cos of how much angle? 0. So this is the answer. So that is the third option. So the options given are QLE 0, minus QLE, minus 2QLE. So most of them will go for minus 2QLE because of the 2A concept. Be careful, okay? Clear? So we'll stop with this. The next class, I'll do some more problems, right, based on this chapter. And I'll solve the first test question paper also. So is there any specific questions which troubled you in that paper? First paper, first test. We'll see that. I'll solve it in the next class. Okay. Those who are online, we'll wind up this.
Thank you,
Okay,
sir.
sir.
Yeah.
Thank you, sir.
Thank you, sir.